A rectangular tank is filled with water to a height of 40 cm. Two taps A and B are turned on at the same time. Water flows from tap A at the rate of 500 cm3 per minute. Water drains out from tap B at the rate of 800 cm3 per minute. How much water will be left in the tank after 20 minutes? All the water that drained out from the tank is to be collected in two containers such that the height of water in the two containers is the same. The base areas of the two containers are 500 cm square and 300 cm square. What will be the height of the water level in the two containers after 20 minutes? So we know that the tank is filled with water to a height of 40 cm. The length is 50, the breadth is 30, so we need to find the volume of water that's currently in the tank. So volume of water would be 50 times 30 times 40, which is 60,000 cm3. So currently there's 60,000 cm3 of water. But what is happening is that A and B are turned on at the same time, and water flows from tap A at the rate of 500 cm3 per minute. So water is going in at the rate of 500 cm3 per minute. But water is drained out from tap B at the rate of 800 cm3 per minute. So this is coming out at 800 cm3 for every 1 minute. That is to say that the water flowing in is lesser than the water that's flowing out. So there's a net water flowing out of, so water flow out, which is 800 minus 500, which is equals to 300 cm3 in every 1 minute. The question asks how much water will be left in the tank after 20 minutes. So in 20 minutes, the amount of water that will flow out will be 20 times 300, which is equals to 6,000 cm3. So the amount of water that's remaining, amount of water left, would be the volume of water at first, which is 60,000 minus 6,000. And we will get 54,000 cm3 of water that's left. But the question wants us to give the answer in liters, so to put it in liters, this will be 54 liters. This is the answer for part A. Now for part B, it says that all the water that's drained out is to be collected in two containers such that the height of water in the two containers is the same. And the base areas of the two containers are 500 cm3 and 300 cm3. So the water that's drained out, which is this 20 minutes, this 6,000 cm3, has to be put into two containers. So two containers, whereby their base area are different. So one is actually, this is 500, while the other would be 300. But their height must be the same. So you want their height must be the same. Now to find the volume of water in the containers, we can use the base area times the height. So and this height can be h, which means that in part B, the volume of water in one container would be 500 times of h plus in container B, which is 300 times of h, will give me a total volume of 6,000 cm3. If I have 500 times of h plus 300 times of h, I have a total of 800 times of h, and their total volume must be equal to the volume of water that is being drained out. So this will be 6,000. So to find the height h, I just need to use 6,000 divided by 800. And I will get 7.5 cm. which means that the height of the water level in the two containers would be 7.5 cm.